So I've had a lot of students ask me how you convert decimals into fractions. Specifically, they're concerned about converting repeating decimals into fractions when the decimals repeat with more than one digit. So what I thought I'd do is I put together a quick video that just talks a little bit about how that is done, and perhaps we'll give you some insight into the background of the methods that we use for making the changes we do. I have divided this into 4 types. Type 1 is terminating decimals. Type 2 is decimals with 1 repeat. Type 3 is decimals with multiple repeating digits. And type 4 are decimals with digits that do repeat followed, or that do not repeat, followed by those that have digits that do repeat. So I'm starting with terminating decimals because there are some principles in terminating decimals that that are kind of helpful for us when we begin to work with the repeating decimals. So I'm going to start with some that are fairly easy. You probably know how to do these, but there is value in looking at them anyway. So we're going to go ahead and do that. The short version of how to take these decimals and turn them into fractions is essentially you just need to read them the right way. Most of us are used to reading 0.4 for this value you see in front of you. But 0.4 is actually an inaccurate way of reading this. It's a convention we use, but it's really not the best way to read that. In reality, the way we ought to be reading this is to say 0 and 4/10. And when we're changing these decimals into fractions, the reason it's so important to read it the right way is because when I say 0 and 4/10, I'm actually saying the fraction 4/10. It's literally as easy as reading it properly to turn terminating decimals into fractions. Now, of course, we do have to go through and simplify those fractions, but that's really not the topic or focus of this video, so I'm not going to spend a whole lot of time doing that. For example, B, 85 hundredths. 85 hundredths is 85 over 100, and of course we have to simplify that as well. I believe both those can be divided by 5. I think that comes out as 17 over 20. When you have 3 decimal values, you have a tenths place, a hundredths place, and a thousandths place. This is 242 over 1,000, which is 121 over 500. D is 5 and 86 hundredths. That's 5 as your whole number, 86 hundredths as your fraction. 5 and 43 fiftieths is the simplified version of that. Here I have 12 and 3,562 over 10,000. That's going to be a little bit messy, isn't it? Over 10,000. That will simplify, I know, because it's even, but doing that is going to take me longer than I care to spend in this video because this is not a video on simplifying fractions. I'll leave that to you on your own. So for terminating decimals, we're going to use the proper name or correct name, and the fractions basically write themselves. Then, of course, we simplify. The second type deals with decimals that have 1 digit that repeats. Decimals with 1 digit that repeats. The way I ordinarily teach this to my students is actually by teaching it in reverse, taking fractions and turning them into decimals. We find that when we have the fraction 1/9 and we try to turn it into a decimal, this is 1 divided by 9. 9 won't go into 1, so I add the 0. 1 times 9 is 9. And notice I get a 1 again. If I attempt to drop a 0 and divide that again, it comes out as 1. 1 times 9 is 9. 10 minus 9 is 1. And you can see I'm always going to get the exact same thing. 10 minus 9 is 1. And so I say that this is 0.1 repeating. What's really cool about this is if I do 2/9, the same thing happens. 2 divided by 9, it goes in 0 times, I drop a 0. 2 times 9 is 18, remainder of 2. Drop a 0, 2 goes into 9 goes into 20 2 times, that's 18, remainder of 2. This is 0.2 repeating. In fact, every single digit that repeats, 0.1 repeating is 1/9. 0.2 repeating is 2/9. All of them are ninths. 0.4 repeating is 4/9. 0.5 repeating is 5/9, 6/9, 7/9, 8/9, and 9/9. Now, there is some other interesting mathematics in here that is not really our focus again today. For example, 3/9 is 1/3, 6/9 is 2/3, and 9/9 is the same as 1/2. I really don't have time to get into all of that because that's not our priority today. Once I've had my students turn my fractions into decimals, I just simply have them memorize that the decimals are always a ninth. That's sufficient for them at this point. Decimals with one repeating digit are always fractions with a denominator of 9, and then of course we go back through and simplify. Once I've done that, we begin to talk about decimals with multiple repeating digits, and I have to use a different strategy. Now, I will tell you the strategy I use for decimals with multiple repeating digits will also work on single repeating digits, but it really isn't an efficient method for doing that, so I don't go back and teach it. I just teach the memorization, and most of the students find it pretty cool that it is always a denominator of 9. For multiple repeating digits, we have a really cool technique that we like to use to get rid of the repeats in the problem. Notice, for example, this is 0.85 repeating. That's actually 0.858585 on and on forever. X equals that. I'm going to assign a variable to this because the variable is going to give me an algebraic way to think about the problem. The challenge is, how do I get rid of the repeats so that I can get a numerator that makes sense? And here's the thing that's cool. I'm going to look at the repeats. This one has 2 repeats. And I'm going to try and move this decimal around those 2 repeats by multiplying by 100. I know that's a little weird. Bear with me for just a second. So down here I have 1x is 0.85 repeating. If I want to move my decimal 2 places, I have to multiply it by 100. 100 times 0.85 repeating makes this into 85.8585, and on forever and ever. I now have 2 equations. One where I have a value of x equal to my original repeating decimal. One where I've multiplied through the whole thing and made the top 100x equals 85.85. And now I'm going to use some subtraction. Now, in reality, this is actually solving a system of linear equations, but in a pre-algebra class, we don't really have that notion in place yet, so we're just going to talk about this in terms of subtracting. 100x's take away 1x is 99x. When I go to subtract this other side, something cool happens. 5 minus 5 becomes a 0. 8 minus 8 becomes a 0, 5 minus 5 becomes a 0, 8 minus 8 becomes a 0, 5 minus 5 becomes a 0, 8 minus 8 becomes a 0. And in fact, since those line up, all the 8s and 5s will subtract and become zeros on into eternity. 5 minus 0 is 5, 8 minus nothing is 8. We've taken our 2 equations with repeating decimals and created a third equation that does not have all the repeats. This is very cool because now I have an equation 99x equals 85 that I can just solve for x using the property of equality. Now, ordinarily in a pre-algebra class, I would not use the term property of equality, but for the sake of the YouTube video, I'll go ahead and put it in place. 99 divided by 99 leaves you 1x. 85 divided by 99 is, in fact, your fraction. 85/99 is equal to x. X was equal to 0.85 repeating, so 0.85 repeating is equal to 85/99. Now, I do have a calculator here, it just happens to be laying on my desk. This is more coincidence than anything else. But if I were to take that fraction 85/99 and divide it out, 85 divided by 99 comes out as a 0. 85 divided by 99 equals, there it is, 0.8585858585, on and on and on. If I can get that out of the glare. It's very, very cool. I'll do another one just to give you a second example of how you do this. And I'm going to try something a little more complicated. And then I've got 2 more examples you can try over here on your own. The second example has 2 repeats. And so I'm going to multiply by 100 to get rid of my repeats. X equals 0.727272 on into eternity. If I multiply by 100, it's now 72.727272 into eternity. Notice one copy of the repeat is before the decimal. Everything after the decimal lines up and becomes zeros. So that when I subtract these 2 equations, 100 minus 1 is 99x. 72 minus 0 is 72. I can divide both sides by 99, and I get x is 72 over 99. Now, in this case, it will simplify and become 8/11ths, but there again, the simplifying is not really the focus of this video, so I probably won't simplify all of them for you. It's worth taking some time to go ahead and do the 0.54 repeating and the 0.23 repeating on your own. My personal suggestion to you is that you pause the video and try that. I will not work them out completely, but I will tell you that what the answer is as soon as I think you've paused it and done it yourself. I think that's long enough. This comes out as 54 over 99, which does in fact simplify to 6 over 11. This comes out as 23 over 99, which does not simplify. You might have noticed something that is a pattern that could be useful to you. I'm not going to mention what the pattern is, but if you happen to see the pattern, it might be worth trying that pattern on a calculator a few times with different numbers and seeing if you are correct, because that can save you a lot of trouble down the road. Here again, we're going to set the decimal equal to x. We're going to multiply my equation by a power of 10 so that one copy of the repeat is to the left of the decimal, and then we are going to subtract the equations. If I have something that's a little larger than that or has more decimals that repeat than that, for example, 0.144 repeating, this has 3 repeats or 3 items after the decimal, so I'm going to multiply it by 1,000. X equals 0.144144. 1,000x moves the decimal 3 places, and I get 144.144.144.144 on into eternity. When I subtract those, I get 999x equals 144. I'm running out of room here. I divide both sides by 999. That becomes a 1. X equals 144 over 999. Now, I will leave it to you to simplify that because it does simplify, but that is not really the focus of the video today. If you picked up on a pattern with 2 repeating decimals and you noticed the pattern with the 1 repeating decimal, you probably noticed something interesting with the 3 decimals that repeat as well. I'm not going to mention it to you. If you can't find it, you'll have to think about that more on your own. Last one. If I have a whole number, I just ignore it. It really is it's just going to get in the way. I'll tack it back onto my final answer in the end. Notice there are 4 digits behind the decimal. So my first equation is going to be 0.1562 on forever. My second equation is going to have to be 10,000x. 1, 2, 3, 4 times around the decimal is 4 zeros. And I made this a little too tight. 1562.1562, 1562 on into eternity. I subtract those. This is 9,999x equals 1562. Notice the 1562. Those all go away into eternity. I divide by 999, and I get x equals, I'm going to come up here and put my 5 back on, 5 and 1562 over 999. And there's your answer. Here again, that may simplify, but I don't want to take the time to do that because that'll distract us from the actual conversion, which is the focus of the video today. That takes us to the last type we look at, and that is where one of the digits repeat, or does not repeat, but the others do. And then really this will work for any number of digits that do not repeat. We're going to do a couple things. Just like before, we're going to set the decimal equal to x. Okay? And then we're going to create 2 equations. So x is going to equal 0.018, where only the 1 and 8 repeat. I'm going to create 2 separate equations this time. In one of them, I'm going to multiply by a power of 10 so that one iteration or copy of the repeat is to the left of the decimal. That's going to be my first equation. So, in this case, I'm going to go 1, 2, 3 decimal places over so that 18 is before the decimal. 3 decimal places requires 3 zeros, so I'm going to multiply by 1,000. That is 18.1818 on into eternity. My other equation, I'm going to multiply by a power of 10 so that the first iteration is immediately to the right of the decimal. In other words, I don't want the first repeat before the decimal. I want the repeats right up against the right side of the decimal. Well, that just means I need to move the decimal 1 place. Moving 1 place means I just need 1 zero, so I'm going to do 10. That's the hardest part. Remember, 1 copy of the repeat before, all the copies right up against the decimal. When I subtract that, 1,000 minus 10 is 9,990. 18 minus 0 is 18, and of course all the rest of these go away all into eternity. Divide both sides by 9,990, and you get x equals 18 over 9,990. And of course that will simplify. This one looks pretty easy. I think that's 2 over 1110, which is 1 over 5, 5, 5. And there you go. I want to try that again. That's a little tricky, isn't it? Let's do that again. I want 1 copy of the repeat immediately to the left of the decimal. So I would like this to be 63.6363 on into eternity. To do that, the decimal has to go over 4 places. That's 4 zeros, which is 10,000. My second equation, I would like to be immediately to the right of the decimal. That means I need to move my decimal 2 places, which is 100. When I do that, 10,000 minus 100 is 9,900x. 63 minus 0 is 63, and then these all go away into eternity. Divide both sides by 9,900, and you get x equals 63 over 9,900. I really don't want to get in the habit of simplifying all these, but it's really almost a compulsive behavior now that I almost can't leave them not simplified. But that's not our focus. Here's one. Try this on your own if you get a chance. It's slightly different. I'll let you pause the video. Once we've done that, you can go back and try it again and watch the way I do it. If x equals 0.1127 and the 127 repeat, the rules don't change. I still want my first repeat right against the decimal. Actually, let me rephrase that. I said that wrong, didn't I? Right up against the left side of the decimal. Notice I had to move my decimal 4 places, so that is 10,000. I'm starting to get a little sloppy here. Let me ease that up for you. So 10,000x equals the whole thing. I would like my next one to be right up against the decimal. Notice only the repeats are on the right. That one that does not repeat is on the left. In order to do that, I had to move my decimal 1 place. So this is 10x. When I subtract, I get 9,990x equals 1126. And all the rest of this goes away. Divide by 9990, 9990. X equals 1126 over 9990. That one I will not simplify, but certainly you can do that. So we're going to multiply by powers of 10 to move the first equation, so one iteration is to the left of the decimal. The second equation we're going to multiply by powers of 10, so one iteration is immediately to the right of the decimal. Just like before, we are subtracting the equations, and then we're going to use the property of equality to solve for x. Here again, with my 7th graders, I normally don't talk about the property of equality at this point. If you have a whole number, I'm going to recommend you set it aside and just use it at the end. Once you have the fraction, it really just gets in the way. In this last example, let's say that only the 2 and the 4 repeat. Only the 2 and the 4 repeat. So this is 0.3324. I need one copy of the 24 immediately to the left of the decimal. That's 242424. And then I would like my first copy immediately up against the decimal. 3224, 2424. In order to do that, the first one had to be multiplied by 10,000. The last one had to be multiplied by 100. This is 9,900x equals, oh, this is going to be fun. 32, let's see, it's 1, 12 minus 3 is 9. 3291, I believe, is my number. Please don't comment if I mess that up. Just let me feel like I got it right. X equals 3291 over 9900, which of course will simplify. Don't forget you've got that lingering 5. This is 5 and 3291 over 9,900. I hope that's been useful to you. If it has, please make sure you like and subscribe to that. Make sure you turn on your notifications so you can get any updates that I put out there. If you have any helpful comments or if this has been helpful to you, make sure you leave me a comment so that I can continue to improve and to make sure that you get videos that are worth your time. Thanks again. Have a great day.